Hello everyone, welcome to my channel. Now let us discuss additive law of probability. So it is also known as theorem of total probability. Now it says that total probability that one of several mutually exclusive events A1, A2, so on up to AN will happen is the sum of the probabilities of the separate events. So, if there are several mutually exclusive events, A1 up to AN, and the probability of happening is the sum of the probabilities of the separate events. So, when probability will happen individually or for separate events, and we sum it, if we add it, this will give the probability of several mutually exclusive events. Now, how we can prove it? Suppose there are n number of total exclusive, exhaustive, mutually exclusive and likely cases. Suppose there are n number of exhaustive, mutually exclusive and likely cases. Now out of these n cases, let M1, M2, so on up to Mn be favorable cases respectively to events A1, A2 and AN. Suppose there are n number of events like A1, A2, AN, and for each event the favorable cases respectively will be M1. That means M1 for A1, M2 for A2, and so on. M3 favorable events for A3 and so on. And since the events are mutually exclusive, the favorable cases M1 up to Mn are distinct and non-overlapping. So it is assumed that the cases are mutually exclusive. That means impossible does not happen. The favorable cases are M1 up to Mn. So therefore, the total number of cases which are favorable to either A1 or A2 or so on of A1, AN is M1 plus M2 plus Mn. So favorable cases either A1 or A2 or A1 or A3 and so on will be M1 plus M2 plus so on up to Mn. So hence probability of sum of the probabilities of events A1 plus A2 so on up to AN is equal to M1 plus M2 so on plus Mn divided by N, that means total events, total likely cases. So this means M1 by N plus M2 by N plus so on up to M1 by N. And this is nothing but probability A1, that means probability of event 1, A1 plus probability of event A2 plus so on, plus probability of event AN. So this satisfies the definitions that we have explained earlier, that symbolically P into A1 plus A2 so on up to AN is equal to probability of A1 plus probability of A2 so on up to probability of AN. So same thing. So this is the additive law of probability or theorem of total probability. So it can be generalized. If events A1, A2, so on up to AN are not mutually exclusive, the probability of happening of at least one of the n events is given by probability of A1 plus A2 plus so on up to AN. So if we sum it, this is equal to probability P into AI, okay, P into AI minus probability of happening AI AJ, because here we assume that are not mutually exclusive. So this must be subtracted. This is equal to minus A1 P into A1, A2, so on, AN. For mutually exclusive cases, probability of AI AJ is equal to 0, probability of AI AJ AK is equal to 0, and probability of A1, A2, so on, AN is equal to 0. Then probability of this is equal to some probability Pi, because in mutually exclusive cases, all these impossibles, this doesn't happen, so they are all zeros. Ultimately, this is equal to this. These minus terms all are zeros. It is the theorem of total probability. So this is the general case that this is equal to this minus this, but in case of mutually exclusive cases, this does not happen. This probability is 0 in all these cases. So that's why probability of A1 plus A2 plus so on over AN is equal to some probability is this. That means some probability of AI means probability of A1 plus probability of A2 plus probability of AN. So this is all about additive law of probability. Thank you for watching. Keep on watching. Please subscribe and share. Thank you very much.